These are some examples that we're going to work through for solving system of equations by graphing. The first thing that we need to do is identify that we have two equations. In this equation, we're going to call equation 1, and this equation we'll call equation 2. The first thing you need to do before you graph the equations is you need to identify the slope and the y-intercept uh, of each equation. So looking at this particular example, we see that the slope is negative 3 over 2 and that the y-intercept is 2. Now, let's go ahead and graph this equation right here. Okay, we know that it has a negative slope, so from left to right, it'll be going downhill, so we know that. We're going to start at 2, and we're going to go down 3. We're going to go down 3 and to the right 2 because it's negative slope. So 1, 2, 3, 1, 2. And we're going to put a little dot. Then we can come up here and we can get a line tool, and we can put a line through that like so. Make sure that your line goes off the graph, and go ahead and just go ahead and put you some arrows on there that signifies that the line goes on forever. Now, that is the first line. The second line that we need to look at, the second line, there's the first line. Here's the second line. The second line, the equation is x equals 4. Well, you should know that this is one of the special cases. This special case basically signifies that it's a vertical line. The x tells you the axis is being crossed, and the 4 tells you where that axis, or where on that axis it's going to be crossing at. So we know that it's going to be a vertical line. So let's go grab another line. Before I do that, let's talk about this real quick. The slope for a vertical line is undefined. And that's really all we have to understand. There's no y-intercept. So let's go grab a line and grab our line tool. And let's go ahead and make a line like this. And go ahead and change the color so that we know what it's going to look like. Let's see, we'll make this blue. All right, so we can extend this line. When we extend this line, we see that there is an intersection at this point right here. And at that point is 4 comma negative 4. So the solution to this system of equation is 4 comma negative 4. Now, let's look at another example. The next example that we're looking at, again, we need to identify. There's equation 1. There's equation 2. They're in slope-intercept form. So I'm going to take the first equation, write it over here. And I need to identify that the slope is negative 1/3. Okay? And that the y-intercept is negative 2. Now, let's go ahead and graph this. Keep my colors. Let's see. I need to be at negative 2. Okay, so that's on the y-axis. Now, it's a negative slope, so I'm going to go down 1 and to the right 3. So down 1 and to the 1, 2, 3, right 3. I'll put a little dot there. Now I can draw a line through this. And I'm going to take that. That line will do that. There. There. That's good. And I'll go ahead and change the colors on that one while I have the opportunity. And we'll change it to purple since this is purple and this is equation 1. So that's equation 1. Let's change to, let's go to green. for equation 2. So equation 2, we have it's y equals 1/3 x minus 4. Again, let's identify the slope. The slope is a positive 1 over 3, positive 1 over 3, and the y-intercept is negative 4. Now, we're going to go to negative 4, and we're going to put a dot. That's our first thing that we do when graphing a line in slope-intercept form is go to the y-intercept and put a dot. Our slope is positive 1/3, which means because it's a positive slope, we will go up 1 and to the right 3. So we'll go up 1 and 1, 2, 3. If you go ahead and can see right there, we know that we're going to have an intersection right there. Okay? So let's just go ahead and get my line drawn here. All right. And let's go ahead and get the colors of that change to green. All right. And we can see that they intersect right here. The point of intersection just happens to be 3 comma negative 3. Okay. 3 comma negative 3. That is the solution to this system. Meaning, if I were to plug 3 in for x and solve for y, such as in the t-table, I will get negative 3. And if I were to plug 3 in for x here and solve in terms of y, then I would get negative 3 out there. That is the point which satisfies both equations. Okay. This concludes 2 examples on graphing system of equations.